Hello, everyone. I'm very happy to be here. This is my first time to come to Hacker in a Box Security Conference. Today, I would like to share my precious work with you. My name is Chen Chen, and the topic to be shared is a journey into Synology NAS. I'm a senior security engineer of Qihu 36011 team. Currently, I mainly focus on the security of embedded devices. I have found nearly 280 vulnerabilities on devices, from Soho routers such as D-Link Netgear to business devices such as Synology NAS, Micrological OS, and switches, routers, firewall from Cisco, Ubiquiti, JTAG, and so on. Also, I have shared some of my researches on other security conferences. Before we start, it should be noted that all the opinions expressed here are solely on my own. Here we go now. This talk is broken down into 4 parts. And part 1, I'll start off by introducing the related stuff about Synology NAS. In part 2, I'll spend some time explaining how to set up a Synology NAS environment for later research. In part 3, I'll dive into the Synology NAS from both the local and remote perspective, then share some vulnerabilities found in detail. Part 4 is a summary of this talk. Start with the introduction. Before you look into the interlude of the Synology NAS, you start at the beginning. What's the NAS? The full name of NAS is Network Attached Storage. It's a small storage device that connects to your home or office network. You can store all the files on NAS, from important documents to precious photos, music, and video collections. What's the most important is that you can access and share these files conveniently. You may wonder why choose to use NAS, whereas most data storage solutions are either local or cloud-based. A NAS device is like a mix of two. On the one hand, NAS devices are functionally similar to any other kind of external hard drive you may have used before, but also provide the remote access and sync capability. On the other hand, you can benefit from the NAS devices, the convenience of cloud storage, without giving it all away to a potentially trustworthy third-party company. Then, why do we choose Synology NAS? Here are the top NAS vendors from Amazon. Among of them, Synology, a Taiwanese corporation that specializes in NAS appliances, is often the best seller. It's described as a long-time leader in the small business and home NAS area. In addition, it has become one of the toughest in Palm 20 Tokyo 2020. Synology's line of NAS is known as Disk Station for desktop models, Flash Station for all flash models, and Rack Station for rack mount models. In this talk, we will focus on the disk station. As to each line, it provides several different scenarios to meet different needs. The coverage ranges from personal and home user to IT enthusiast, to small and mid-sized business, to enterprise. In addition to disk station, the disk station manager is worth being mentioned here. is based on Linux and an intuitive web-based operating system for every Synology NAS. It provides rich features such as file syncing, data backup, cloud service, and so on. The aim of it is to provide better flexibility and usability in every aspect. In the past few years, there have been some security news related to Synology NAS. Among of them, two are ransomware attacks. The nature of NAS makes it a good target for ransomware. Besides, it should be noted that the DS115G model was hacked in GeekPwn 2018. The player got the root privilege on the device with a buffer overflow vulnerability. And in Pound Tokyo 2020, another model DS418 player was hacked again by two teams. Both of them got a root shell on the device successfully. However, currently, there are still not much details about this vulnerability in public. I'm not the first to assess the security of Synology NAS. Of course, not the last. There is a white paper published by NCC Group in 2017. They discuss in detail the analysis performed, methodology used, and the vulnerabilities found. In addition to that, the researchers from ISE assessed the security of certain Soho router and NAS devices, including the Synology NAS. Recently, the Cisco Taylor team conducted a security analysis on the Synology SRM and DSM. They mainly focused on its quick connect feature and discovered multiple remote vulnerabilities. On the basis of them, I try to reveal more intelligence of Synology NAS itself, of course, with more vulnerabilities in detail. Alright, you know about me, you know about the Synology NAS. Let's move on to the next part. Set up an environment for security research. First, we need something to test on. Currently, there are two ways. Either you can buy a device directly from the Synology, also called white Synology. It's easy to set up and use, and has complete features, but may be a little expensive. Or you can assemble a device with custom hardware and install the official DSM, also called Black Synology. In relative, it's much cheaper and has most features, which is enough for our research. As to Black Synology, thanks to the community, it's possible to create a NAS virtual machine. What we need are a visual path file from the vendor and an UEFI or BIOS loader from the community. After the virtual machine is started and the loader is loaded, we can configure the device and install DSM either through the Web Assistant or Synology Assistant. Then we can access and manage it via browser. Unfortunately, there are some trouble installing the latest DSM version in this way. What if we want to test the latest DSM version? The virtual machine manager provided by Synology comes to rescue us. It's an intuitive hypervisor software and integrates various visualization solutions. With it, we can run multiple virtual machines on the Synology NAS, of course, including Synology DSM instance. In short, we can create an older NAS virtual machine with VMware Workstation or something similar. Then run multiple virtual DSM instances inside it. By the way, the Docker package is a lot lighter-weighted virtualization application provided by Synology, which can run virtual DSM as well. However, Docker DSM reached the end of life on December 2019. Now, we have both the DSM 6.2 and the DSM 7.0 environment. Since the latter is still on beta stage, and a lot of what the features are yet stable and mature. In this talk, we mainly focus on the DSM 6.1 or 6.2 version. By the way, the Synology also provides online DSM demo for experience. Maybe you can conduct research based on that. Lastly, for bug hunting, it's necessary to access the Linux shell on the device. Fortunately, the SSH is available. Moreover, the ability to debug the program is pretty fundamental. To our delight, there is a utility packet called Diagnosis Tool. We can install it from the package center. Sometimes, if you can't find it in the package center, an alternative way is to install it from the terminal shell with the command synology install. After installing it, there are many utility tools available, like GDB and GDB server. Now, everything is ready. Let's go into the most important part. Since the device is network reachable, suppose you are an adversary. What can you do if you are in the same local area network as the device? First, let's start with service probing. As we can see, there are many service sites listening on the device, including common service sites such as Nginx, Mini SSDPD, SNMPD, and so on. Also, there are some customer services, namely Find Hostd, ISCSI, Snapshot Comcall, Silo SNMPCD. As for me, I prefer the customer services, for it seems to be less tested and more vulnerable. So let's look at the service Find Hostd. In short, it's responsible for communicating with the Synology Assistant, which is a desktop utility that searches for disk station in local area network. We can use it to configure the device, such as the administrator password, the way to obtain an IP address, and most importantly, install the DSM on the device. Now, you may wonder, how does the Synology Assistant communicate with the Find Hostd? Here is a simple communication flow between them. First, they are communicated via line UDP port. In general, the Synology Assistant firstly sends a broadcast query packet, and the Find Hostd sends both a broadcast and a unicast packet as a response. After finding the device, the Synology Assistant can continue to send other broadcast packets, such as configuration packet. Similarly, the Find Hostd sends both a broadcast and a unicast packet as a response. Here are some text captured during installation. As mentioned before, the messages are sent via broadcast. Also, they are clear text. For we can see information such as MAC address, server name, serial number, model, and so on. To get a better understanding of the message format, reverse engineering is necessary. As a result, some clues are found. First, the message begins with a magic. Then, there is a large chunk of data, which indicates the format and the meaning of the remaining part. For each data chunk, it has 6 fields, as this structure shows. Specifically, the packet ID field indicates the meaning of data, such as packet type, username, or MAC address. The offset field means where to put the data in the buffer. The max length field limits the length of data. With this information, the packet can be disassembled like this. The first part is magic number. The remaining part is composed of many segments. Each segment has 3 fields: packet ID, data length, and data. Moreover, for integer data, its length is fixed and equal to 4. For string data, it has a variable length. Sadly, to make it easier to disassemble the package, a Wireshark plugin is created. With it, we can have a better understanding of the packet format. By the way, this plugin is publicly available. Since we have loaded the message format between the final host D and the Synology assistant, let's get it deeper. The value of packet ID 1 indicates the type of whole packet. Some common packet types are broadcast query, let setting, quick conf, or memory test. Among of them, some packets such as let setting, quick conf, and memory test packet contain an encoded administrator password, whose packet ID is 2A. A sample of quick configuration packet is shown. As we can see, the packet ID 1 has a value of 4, which means it's a quick configuration packet. The packet ID 2A contains the encoded password. Through reverse engineering, it turns out that the encoded password is decoded by calling function matrix decode. Here comes the first issue. Remember that messages are sent via broadcast in plain text. As a result, in some cases, an adversary can easily steal the plain text administrator password by monitoring the broadcast traffic. Next question is, how robust is the code for parsing the packets? Because I'm too lazy to access it manually, so I resort to protocol fuzzing. I prefer the KT and SCAPI framework, which is very convenient and flexible. With SCAPI's power, we can define the protocol format easily and quickly. On the one hand, with the KT framework, we can reuse the predefined protocol format to build a black box further easily and quickly. Moreover, thanks to the community mechanism, we can fuzz both the final host D and the Synology assistant at the same time. On the other hand, with the predefined protocol format, we can also build a simple Synology assistant client with Python. One of the issues found by fuzzing is related to Synology assistant. During fuzzing, my already configured device becomes not configured. Did some corrupted packets reset my disk station? After investigating it, it turned out that some corrupted packets deceived the Synology assistant. My disk station is okay, but the Synology assistant thinks it's not configured. Normally, in this case, you may choose to reconfigure the device via Synology assistant and set the username and password used before. Again, since the messages are sent via broadcast in plain text, password leakage comes back. In summary, an adversary can cheat the administrator into reconfiguring the device, then steal the plain text administrator password by monitoring the broadcast traffic. It's worth mentioning that in most recent Synology Assistant or DSM versions, an encryption mechanism for communication is introduced. As we can see, there are two magic laws. One is for plain text message, and another is for encrypted message. And some new PKID items are added for supporting encryption. In addition, if the target DSM doesn't support encryption, there will be a warning message shown in the Synology Assistant. In spite of this, even if both the Synology Assistant and the DSM are the latest version, it's still possible to do password stealing. Next, let's take a look at the service ISCSI/common core. ISCSI is a protocol to facilitate SCSI-based storage commands to be sent over ubiquitous network structures. Two related processes are ISCSI/common core and ISCSI/server. The communication between them are outlined as follows. First, the ISCSI/common core receive and pass data from external socket, then send the data to itself through pipe. After passing the pipe data, send it to the ISCSI/server through pipe again. The ISCSI/server pass the pipe data and execute corresponding commands, such as delete snapshot, start mirror, and so on. With a general understanding, let's look at it in detail. In the stage 1, the following code snippet is responsible for reading packets from socket. As we can see, before the memory copy function, there is a signed integer comparison, and the v4 variable is passed to the memory copy function as the size parameter. If the variable v7 is a negative number, then the size of data to be copied will be very big, thus causing an invalid memory access exception. Since the v7 is the return value of A2 function, it's clear that when the third parameter is 0, the if condition will satisfy and a negative 1 will be returned. Further, the third parameter comes from a large socket data at position 4, so it's controllable. As a result, by corrupting a packet, we can trigger overflow when calling memory copy. However, during memory copy, an invalid memory access exception will occur. Here is a snapshot about the crash. By the way, this issue was fixed silently by the vendor, for I couldn't find any information related to it. Suppose we ignore it and come to the stage 2, the ISCSI/common core pass the data and call related functions. There are many functions with a prefix handle. Among of them, function handle send message and handle receive message are different according to an inner structure. Take the function handle receive message as an example. It will call function Apple send control eventually. It should be noted that the set parameter comes from the received message and is controllable. Then we reach the stage 3. The Apple send control function will send the data to ISCSI server through pipe. The function packet write is responsible for this. Its first argument comes from the set argument of Apple send control function. The create packet function is called to build a packet. Each side of it, first call the dialog to allocate a buffer, then call memory copy to fill it. Since the size parameter of memory copy is controllable. On the one hand, if a small large value is provided, it will read beyond the buffer pointed by A2. This case is similar to the open SSL heartbleed vulnerability. On the other hand, if a big large value is provided, then an integer overflow will occur when A3 plus 32. As a result, the size passed to tdialog will be 0, while the copy size of memory copy will be very big, thus causing an invalid memory access exception during memory copy. According to this inner structure, all other functions have a predefined length value. Only these two functions don't have, which leads to this issue. Again, here is a snapshot about the crash. By the way, it seems that the vendor didn't fix this vulnerability after I reported it on Pong2O Tokyo 2020. The Star Labs team changed this out of boundary vulnerability with other vulnerabilities and achieved remote code execution against the DS418 player model. Congratulations to these guys. Suppose we ignore it again and reach the stage 4. The ISCSI server will read data from pipe and deal with it. The function handle plot command will be called in normal routines. The main logic of handle plot command function is convert the received data into JSON object and resolve some case such as command SN, plugin ID, and so on. Among of them, the command parameter will be used to search the corresponding handle function, which will be called later. As we can see, there are many supported commands, like register, connector, start mirror, delete loan, and so on. Take the delete loan command as an example. The corresponding handle function is handle plot delete loan. In handle plot delete loan function, it will simply get the required parameters, then call Silo ISCSI loan delete function to delete loan. Surprisingly, no authentication is required. In consequence, it's possible for an unauthenticated adversary to delete the loan on the device, which may pose threat to our data. Okay, so far, we suppose we are in the same local area network as the device, but in reality, NAS is often used in remote series, which can be accessed over the internet anytime, anywhere from any device and browser. That is, maybe only port 5000 is available in this situation. By simply searching the online device through Shodan, it turns out that, indeed, only a few ports are accessible. Again, suppose you are an adversary. What can you do in this remote situation? The first question to consider is, how can you determine whether the device behind this IP is a Synology NAS or not? What's more, if it is, what's the version of it? What packages it install, and the corresponding version. This is all about device fingerprinting. To our relief, there are some clues in the index page. As we can see, there are some CS references indicating which inbuilt models and third-party packages are available. In addition to that, there are some unique script links for Synology NAS. With this information, we can build a more precise query used for Shodan or something similar. Then, how about the version? An extra V parameter is attached to each link. In general, this parameter indicates the last modified timestamp, that is, the build timestamp. Based on it, we can infer the corresponding version. Take the last link as an example. The timestamp can be converted to this datetime after searching in the Synology firmware archive. There is a high possibility that the version of DSM is 6.2.3.25426. Similarly, the version of audio staging package is 6.5.6.3377. Next, it's necessary to understand how does it work in remote access situations. When accessed remotely, the only entry is through port 5000. That is, all the requests are sent to the device via this port. Here are some requests captured during a normal login operation. As we can see, there are several URLs requested, such as query.cgi, login.cgi, and entry.cgi. The picture on the right is a simple workflow to interact with the device. Step 1 is to retrieve API information through query.cgi URL. Step 2 is to log in to get an authorized session ID through encryption.ci and login.ci. With the session ID, then you can send an API request via entry.cgi and pass the response. After finishing the interaction, you can log out to end the login session. With a general understanding of the workflow, let's see how to make a specific request. Take this picture as an example. The request is sent in a JSON API. The endpoint for most requests is /webapi/entry.ci. In the post data, the API parameter indicates which API will be requested. The method parameter is the method supported by the API, and the version parameter is the version of API requested. Above is what we can see from the front end. How is the request passed in the back end? Synology uses a metadata file to define information related to API requests. The name of this metadata file has a prefix sylo and a postfix lib. Part of content is as follows. Specifically, this is the API name specified in the request. The allow user field indicates which group can access this API. The auth level field means if authentication is required or not. 0 means no authentication. The lib field specifies the path of file to handle this request. The message part contains the version number and the message supported by this API. Also, the allow user field can be redefined in each method. So far, we know how to make a specific request to reach the target boundary in the backend. Finally, let's from the whole perspective. Here is a simple and high-level process flow. First, a request is sent to the device via port 5000. Then, based on the request URL, the engine server will schedule the corresponding CGI to handle the request, such as query.cgi, login.cgi, and entry.cgi. Among of them, entry.cgi is the endpoint for most post requests. This CGI may communicate with a large two process, Silo CGID and Silo SCGI. Silo CGID mainly handles session-related stuff, and Silo SCGI is mainly responsible for dispatching specific requests to the target boundary. After understanding the request handle mechanism, you may wonder what API you can reach to. Actually, there are many API. In general, two main attack surfaces are exposed: the DSM itself and the various packages. Let's start with the DS file app. The apps provided by Synology make it easy and convenient to manage and access your disk station from mobile phone. One of them is DS file. With it, you can browse, transfer, and manage files on the disk station easily. The API flow is similar to that via web portal. When trying to log into the disk station, in normal case, PKI-based encryption is used for authentication. But what if you input a wrong IP or name, or the network is temporarily not available? As to these two cases, since the first request will fail, two more requests will be made. Let's get a close look at it. Surprisingly, the second request contained a base 64 encoded account information, which is equivalent to plain text. To conclude, if you try to access your disk station by DS file app in an unsafe network environment, by simply dropping or redirecting specific requests, MITM adversary can obtain the plain text password. It applies even if HTTPS mode is used. Next, let's look at the Synology Calendar package. It's a web-based application for organizing and planning out daily events. It supports shared calendar within a group of people. Also, adding attachments to event is supported. So, how does attachment work? When trying to attach files, one way is to upload from your computer. Another is to upload from Synology NAS. The following is the request when trying to upload from Synology NAS. It turns out that the file path is not validated properly, and suffers from directory traversal problem. By injecting // into file path parameter, it's possible for normal users to read files out of the shell folder. After a normal file is attached, the link behind it is as follows. As you may notice, the file name is also a part of the link. So, can we control the link by providing a crafted file name? The answer is yes. It assumes that the file name is not validated before adding into the link. As a result, by crafting a file name, it's possible to change the link to what we want, and also make the file name look normal to users. Moreover, we can share this event within an administrator group. When one of the users in this group tries to click the attached file, the request we controlled will be executed. In summary, it's possible for normal users to execute arbitrary requests in the context of administrators, such as adding itself into the administrator group. The second package to discuss is a media server. It provides a multimedia service to browse and play the multimedia contents on NAS via DLNA or UPnB home devices. After installing it, some custom services will be started, and after a simple analysis, to our delight, some URLs can be accessed without authentication. One of them is the video transcoding.cgi API. Here is the requested URL format. Part of the code snippet to handle the request is as follows. It expects the URL to be in a specific format. But what if the URL violates the format? It's obvious that by crafting a URL like this, we can track integer and flow when calling string uncopy. Suppose we provide a normal URL as the code expected. The routine will continue, and the function sub403f50 will be called. In function sub403f50, it will simply check the argument A2, then format the argument A3 into a secure statement. Since the argument A3 comes from the URL, and there is lack of proper validation, by crafting a URL like this, we can track the secure injection vulnerability. Another similar and interesting API is jpeg-scala.cgi. Here is the requested URL format. Part of the code snippet to handle the request is as follows. It's clear that due to lack of length check when calling string uncopy, by crafting a URL like this, we can track buffer overflow. The last packet to share is audio station. It allows you to enjoy high-quality playback, listen to radios, and manage your music collection. Similarly, after installing it, it has some custom CGI files, which seems attractive. Recall the HTTP request process flow. The execute CGI path is used for handling custom CGI requests, and in some cases, authentication is checked in custom CGI files. Following are some examples of how to reach the custom CGI endpoints. The most appealing CGI file is audio transfer.cgi, and here is the requested URL format. Let's get a close look at it. In main function, sub403f50, 402.730 function will be called at the beginning. In function sub 402.730, it will get the last part in URL path and pass it into function media ID decryption. It's worth mentioning that there is no authentication in this routine. In media ID decryption function, it will first get the length of argument A1, then call SM printf function later. As we can see, the size and the buffer point of SM printf function is controllable. It's trivial to trigger the buffer overflow. In consequence, an unauthenticated remote adversary may achieve code execution on the device. So far, we only cover a few packages and discuss the vulnerabilities found in them. Actually, Synology NAS has rich inbuilt features and lots of third-party packages. At the same time, it will release its product security updates officially. And combined with the Synology firmware archive, it's great for us to do patch analysis and bug hunting. The following is the demo, which will exploit the buffer overflow vulnerability in the audio staging package to get a root shell on the device. First, we checked the version of DSM in built models and third-party packages. It turns out that the audio staging package is installed and its version is vulnerable. Then we run a POC against it and try to get a reverse shell. Successfully, we got a root shell. In the last part, let's recap what we have talked. First, we learned how to set up an environment for security research. Then, we discussed the common attack service, such as the protocol used to search and configure NAS in local area network, and those exposed by Disk Station Manager and third-party packages. Also, the HTTP request process flow is depicted, including how to reach the API we want. Last but not least, some vulnerabilities are shared in detail. For those guys who are interested in this, maybe you can find more vulnerabilities by yourself later. Okay, that's all I share today. Wish you all have a harvest. Thank you.